This will be the third video in this series. I'll put a link to parts 1 and 2 in the description in case you didn't get to see them. So let's look at problem 1. We'll have actually just 2 word problems in this video, and they're very basic. They're problems that you could figure out without using an equation, but generally we want to use an equation because they can get some word problems can get kind of complicated. Let's read the problem. It says the sum of 3 consecutive even integers is 246. Find the integers. Okay, the most important part of a word problem obviously is to read it and understand what it's asking, understand the terms it's asking for. So here we're talking about even integers, so we have to know what the integers are. So let's start with 0, 1, 2, 3, and so on. 3 dots means it keeps going, and then on the left side we have the negatives. Negative 1, negative 2, negative 3, and then it keeps on going forever. Okay, so we have positive integers over here, 1, 2, 3, and of course 0 is neutral. We can also call the numbers 0, 1, 2, 3 whole numbers. We can call them counting numbers. Okay, and then we talk about even integers. So even integers are those that are divisible by 2. So that would be obviously 0 is divisible by 2, 2 is divisible by 2, 4, 6, 8, 10, and so on. Those are the even integers. Now some problems will talk about odd integers. That's just the opposite of the even integers. They're not divisible by 2. So that would be 1, say 3, 5, 7, 9, and so forth. Or on the other side, negative 1, negative 3, negative 5, negative 7, and so on. Okay? And of course then you have the rational numbers. Okay? Those are the fractional. Those are the ones that are fractions. And again, 0, 1, 2, 3 are the integers. They're also called whole numbers. Okay, so keep in mind that when they talk about consecutive, it's one after the other. So if they're talking about just consecutive integers, that would be 1, 2, 3, 4. So in other words, the difference between any 2 is 1. 2 subtract 1 is 1. 3 subtract 2 is 1. Okay, even integers differ by 2. Right? So we have 2, 4, 6. So we just add 2 to get the next one, and so on. Odd integers like 1, 3, 5. Again, the difference between any 2 consecutive odd integers is 2. So to get the next one, we just add 2. Okay? So you have to understand what integer is, what a consecutive integer is, or what is a consecutive even integer, or sometimes consecutive odd integer, and so on. So here we have the sum of 3 consecutive even integers is 246. Find the integers. Now you could work this problem without using an equation. Okay? So you can pause the video and see if you can find them. And then I'm going to work it out using an equation. Okay? So obviously you don't want to start with something like 2 and say, okay, well, the first one could be 2. And then it's even, so the next one would be 4. And the next one would be 6. But obviously those are too small. So you want to pick a larger number if you wanted to do it trial and error. But I'm going to do it with an equation. So okay, you can pause the video and then try to work it out. And then I'll come back. Okay, hope you pause the video and try to work it out on your own. So let's do this. We pick a variable. It could be anything you want, x, y, z, a, b, c, whatever you want. But I'm going to let x equal to the first integer. Okay, here we pick a variable. Okay, so now we're talking about consecutive even integers, and there's 3 of them. The sum of 3 consecutive even integers is 246. Find the integers. So let's set x equal to the first one. Okay, then you have to say, okay, what would represent the second one if they're consecutive even? Okay, well, it would have to be a number that's too larger than that one, right? So simply add 2 to that one. X plus 2 would be the second one. and then 2 more than that will give you the next one, or the third one. Okay? So this represents then the 3 integers. Okay, so now what does it say? The sum of those integers is 246. So this is saying if we add these together, we're going to get 246. So I set it up. The first one plus the second one, which is x plus 2, plus the third one, which is x plus 4. Then we solve this equation, and that'll give us the first integer, because we're going to solve it for x, which is the first integer. Okay, so obviously there we're going to add the x's together, 1x, another x, there's 3 of them. So it's 3x, and then we add the numbers, 2 and 4 is 6. So we get 3x plus 6 is equal to 246. Okay, 3x plus 6 is equal to 246. And then, of course, we're going to subtract 6 from both sides. Okay, that'll give us 3x is equal to 240, and then divide by 3. Okay, so here I subtracted 6 from both sides. So 6 minus 6 cancels, so it gives me 0. 246, subtract 6 is 240. And then to solve for x, I divide both sides. To isolate the x, we divide both sides by 3. And of course that will give me x is equal to 80. Okay, that's the first one. 2 more than that will give me the second one, and 2 more than that will give me the third one. Okay, so we add 2 to the 80, we get 82, and then add 2 to the 82, we get 84. Those are the 3 integers. And then of course you can check it by adding them up. 80 plus 82 plus 84 will give me 246. But you could have gotten the answer without setting up this equation and just doing a trial and error and finding the 3. Pick one and then add 2 to that and then add 2 to that and get the combination that gives you 246 when you add them. Okay, problem 2. Again, this is one you can do without setting up an equation. But here it is. It says at a football game there were 11,820 spectators. So the total is 11,820. And then it says 8,256 of the spectators were adults. Okay? Adults. Those were adults. Of the remaining spectators, there were 3 times as many teenagers as young children. How many teenagers were there? So we have actually 3 categories here. Adults, and we have a total of 11,820 spectators, and of those 8,256 were adults. Of the remaining spectators, there were 3 times as many teenagers as children. Okay, so we also have teenagers and children. How many teenagers were there? So again, pause the video and see if you can figure this out. Okay, so again, without setting up an equation, you can solve the problem. Okay, but let's set up an equation or do the basic steps here. Okay, so here's some of the steps. If I take the total of the spectators, subtract the number of adults. Okay, so 11,820 subtract 8,256. Subtract those out. Then I get 3,564. This is the number of teenagers and young children total. Okay, so this makes up the total of the teenagers and young children combined. Okay, now I'm going to let x equal to the number of young children. Okay, let x equal to the number of young children. Now what does it say? Of the remaining spectators, there were 3 times as many teenagers as young children. How many teenagers were there? Okay, so if x represents the number of young children, then 3x will equal the number of teenagers. Okay, because it's 3 times that. Now notice, I could have done it also by saying let x equal to the number of teenagers, because that's what we're looking for. Then 1/3 of that would be the number of young children. Okay? Because 3 times the 1/3 x will give us the x. Okay? So there's different ways you could set it up. But this is what we have. So if I let x equal to the number of young children, 3 times that will equal to the number of teenagers, okay? Because of what it says. There were 3 times as many teenagers as young children. So what do we know? We know that the total of teenagers and young children is 3,564. So if I add these two together, x and 3x, right here, 3x plus x, then it should give us the value of 3,564. So we solve this for x. Add the x's together, 3x and 1x is 4x, okay? And then to solve this for x, I divide both sides by 400, so 3566 or 3,564 divided by 4 will give us the 891. No, the x equal 891. That represents, what do we have? We got number of young children. X is equal to number of young children. So what does it say? 3 times that is the number of teenagers, and that's what they want. They want the number of teenagers. So if I multiply the 891 by 3, that gives me 2,673. So the number of teenagers is 2,673. Okay. Again, the setup could be different, or you could just figure it out without using equations. Okay, a little bit. This is a little straightforward if you just set it up in this format. Okay, thanks for watching. And again, there'll be links to the parts 1 and 2 in the description in case you missed those. We'll see you next time.